So this is a basic introduction of Modbus over TCP/IP. This is a brand new feature here, Rev 1.0. So I'm sure this will be updated. But for this new AEV AccelNet EtherCAT Plus micro module, we've got a new firmware 4.18 or greater that allows us to do Modbus over TCP/IP. The TCP/IP will need an IP address, and if we're connected to a host, it can dynamically create the IP address using DHCP. There's another note that we can look at, app note 121. We'll look at that next. That talks about UDP and basic Ethernet. But there is a parameter in the drive, 0x121, which when bit 9 is set, it will put it in an Ethernet mode. So taking it out of the EtherCAT mode and putting it in the Ethernet mode. Other drives will be available in the future, maybe like the Xenos EtherCAT drives and the AccelNet EtherCAT drives, but we'll have to load firmware that does not contain the EtherCAT, so just purely Ethernet firmware. There's also a bit 1 of this parameter. When that's set, it'll use the DHCP, ask the server to provide the IP address. Without that bit set, we'll have to assign our own IP address on the computer and in the drive. So we'll take a look at how to do that later. But the basic idea for TCP/IP Modbus is that they always use port 502. And Modbus can do 16-bit register access. And so those are the functions that we are going to use here. We can read they call them registers in Modbus, not to be confused with CVM indexer registers, but we can read and write the 16-bit parameters in the drive using the hold registers, the read, the hold register, and the write hold register, function 3 and function 16 or function 10 hex. The unit identifier, if this was a multi-axis drive, it would be like A, B, and C axes. This drive only has one axis, so this will be set to 0. The mapping of the parameters in the drive start at 0, and these contain 2 registers each, 32 bits, 2 16-bit Modbus registers, and these registers reflect the parameter dictionary. So these are like explicitly mapped, so you can read and write any parameter in the drive. There's also a starting point for reading and writing the flash versus the RAM. And this is interesting and very useful. These are parameters that are used to do trajectory moves. No, I'm sorry. These are for the longer than 32-bit parameters, like the filters. Excuse me. 2000, these are the trajectory parameters. They call them special commands, but it's for homing and initiating a move and aborting a move. We can also access the CVM indexer registers that are in the drive for if you write a program, you can read and write the drive's registers, not to be confused with Modbus registers. But so, for example, in order to access a parameter, you'd start off with 0 all the way through 3FF for all the parameters in the parameter dictionary. And they're broken down, they're 32-bit parameters in the drive, and they're broken up into 2 registers, high byte, low byte. These are in RAM, and you can access them. For example, We want to look at the actual motor position, parameter dictionary value 0x17, and so it's a 32-bit. So what we do here is we multiply this hex by 2 hex and come up with 2E hex for the upper 16 bits. And of course, 2F is the lower 16 bits. So it's big endian, little endian. The first 16 bits contain the MSB, most significant word, and then the second parameter is the least significant word. Of course, there's flash parameters. 0x800 is the starting point for those. Just add the 2E and 2F to that, and you'll access flash. Longer parameters, blah, blah, blah. Too much to read at the moment. This 0x2000 is the starting point, which values can be 0 for abort, 1 for initiate new trajectory, 2 for starting a homing. If you have some trajectory values set in the drive, you can save these for multi-segment moves, so sort of stack them up. I haven't used this yet, but that's very interesting. CVM program stop and start, so 2001. So 2000 these are the values in this register. 2001 is a command to start and stop the CVM program. You can configure to run it power up. You can read the status of the CVM. So indexer registers for the CVM program start at 4000. So you can read and write the indexer registers. And of course, this is the latest note. Okay, because this is an introduction to Modbus video, there's the Modbus organization, which has some really cool technical resources. And if you look for the TCP stuff, there's a bunch of specs for it and documents and software that you can use. I loaded some software, or free software. I'll show you how that works. But the fundamental is the TCP, and you'll notice the TCP has built-in error checking, and it's complemented with the IP, Internet Protocol. This is for getting the data around breaking it up into pieces and getting it around a network. You'll notice here in this specification for Modbus TCP, it's registered to port 502. So that's the second time we've seen that. It's part of the spec. And this, of course, is an IP address. So this breaks down like where the host is. And anyways, the IP4 address is what you'll set on your PC if you have to assign your own IP address. But we're going to do the DHCP, where we're going to ask the server to give us an address. And it will remember it, and we'll remember it. I'll show you that in a minute. There's a parameter 11F, which contains the host ID. But the dynamic host configuration protocol allows the client to ask the server for an IP address, and it's like a handshaking back and forth, and they work it out. So if you had multiple drives, each drive would have a unique IP address on that network. Just a basic idea. You don't need the checksum anymore in Modbus because it's part of the IP, and you don't need the address anymore because it's part of the TCP/IP. But you do have a function code and a section of data. So this is the application data unit, and here is the PDU. So the data will be defined as 2 16 bits, and then the function code 3 and function code 16 decimal 10 hex are the ones that I'll be showing. We can see from the wiki Modbus definition for TCP, there's read multiple hold registers. This is function code 3. And there's write multiple hold registers, decimal function code 16 or hex 10. And these are 16 bits. So two of these registers, I guess, would hold the 32-bit. We'll take a look at the app note 121, which is mentioned in the previous app note. So this talks about UDP, but it means EtherCAT. But the important things, again, are the parameter 121 in the drive. Bit 9 is set to use the UDP or Ethernet mode and not the EtherCAT. And bit 1 needs to be set in order to do the dynamic host config. And you can see this parameter. I did not find this in the parameter dictionary yet, but it's 11F, which contains the IP address. It needs to be a valid IPv4 address, but we'll have it assigned. Here's an example of an address. The UDP talks serial binary. We won't worry about that. The UDP can do ASCII commands. We won't worry about that. There's a little blah, blah, blah about the IP address assignment for UDP. Of course, we don't worry about that with the TCP. And firmware 4.14, we should be up to 4.18, the dynamic host config. And yeah, it mentions bit 0 to be set in the register 121, the parameter 121 in the drive for DHCP, and it'll assign the IP address to 11F in RAM and then in flash. And then, of course, the host will recognize the drive IP address in flash and its serial number, so that all gets worked out by the host. So we don't have to worry about any of that. So this introduction is almost over, but I'll show you. I got this PMod master, Modbus master, and I just downloaded the zip file and I unzipped it, and then I just put it in a folder, and then I'm running it from this folder. Pretty simple README procedure provided for free, and you get this Modbus. I'm going to save configuring the drive and using this for the next presentation, because I'm going to get cut short here, but this comes with good descriptions of Modbus, and it's a good resource for learning. And again, read the holding registers and multiple write for the registers. These are the two that we're going to use. This will read the holding registers. All right, well, that's it for this introduction, and we'll do part 2 of Modbus with a Copley drive next. Thank you for watching.